All right, we're going to start talking about concept 1.6, which is function notation and definition. So there's just going to be two parts here. So you should have that worksheet that you can follow along with, and I'm going to move us on. So the first thing we're going to talk about is evaluating functions. So you're going to see on your paper 3 different function machines, and we're going to be using those function machines with the equations inside to evaluate functions, all right? So the first thing that you have to know about when you're doing this is that the input, you can see it sort of 2 places on here. The input is both at the top here, it says x equals -3. But in future problems, you won't see that. You'll see the function, which here is f of x equals -2x plus 4. And you'll see in the problem, here it says I'm looking for f of -3. All I did was I replaced the x here with the number -3. Okay? And so what I'm going to do is I'm going to replace x with -3 in the actual equation as well. Okay? And so what that looks like is this. Go ahead and write this on your paper. I just plug in that -3 in where that x used to be. Okay? And then you're just going to simply evaluate that. We don't do anything to this left side. We just keep it f of -3. F is really just the name of the equation, and -3 is the input that we plugged in for x. And so this function notation allows us to see both the input and the output at the same time, and that's kind of what it's beneficial for. So I can see that when I plug -3 into the function f, it looks like that, and we're just going to simplify that right side in purple down to one number. So following order of operations, I'm going to multiply the -2 and the -3 to get 6. And then after that is when you add the 4. Okay, so my final answer is going to look like this. F of -3 equals 10. Okay, so if you look at the next function machine, you're going to see up at the top is where it says -2 because we're plugging -2 into this function. You can see that again down at the bottom where it says we're doing f of -2. So what you're going to do is in the equation, you're going to replace that x with the number -2. Looks like this. Okay, and then all you got to do is evaluate that right side. So following order of operations, there are sort of invisible parentheses around that -2 plus 3. So we're going to do that first. So -2 plus 3 is 1. And then after that, you can do the square root, and the square root of 1 is just 1. So f of -2, when I plugged -2 into the function f, my output was 1. Okay, why don't you pause and try the last one, plugging in 5 for x. Okay, and hopefully you did that. You plugged in 5 for x, and then you evaluated, maybe using your calculator. Remember that 5 to the 3rd power does not mean 5 times 3. It means 5 times itself 3 times. So 5 times 5 times 5. You can also use a calculator to do that. All right, second thing we're going to talk about is function definition. So what makes something a function? And so the definition you're going to write on your paper is that in order for something to be a function, every input or every x value can only have one output or one y value. Okay, so we're going to be evaluating if something is a function or not using this definition, and we're going to do it with graphs and with tables. Okay, so when I look at this graph of this parabola, I'm looking to see, does every x only have one y? Okay, so I look at this graph, and I'm going to look at a couple different points on this graph. So x is our left to right. Okay, where does this graph go? And your y values are up and down. So for every spot on your graph, left to right, there should only be one y value up and down. So if you look at those 3 different dots, so say like I'm looking at this first one up here. Okay, so that's my y value when x equals -2. There's only one dot on that vertical line at -2. Okay, there's only one dot down here if I look at +3. There's only one dot that's on this vertical line at +3. There's only one dot at +4. Okay, so because each x value on this parabola only has one y value, this is a function. Okay, now I'm going to take a look at that circle. On that circle, if, for example, I look at +2, okay, you're going to see how I can draw 2 dots, right? I can draw one dot up at the top, and I can draw one dot down at the bottom. Both of those have an x value of 2, but there are 2 different y values on that circle on the same up and down line. You're looking for that on a graph. If your graph overlaps itself vertically, that means there are two outputs at the same input, and it is not a function. Okay? Now we're going to take a look at what it looks like on a table. So I'm looking for every x value should only have one y value that it goes to. So if you look at this table, if I ask you what's the output when x is -2, you would say -3. That's this row. There's only one answer. When x is -2, there's only one y value for it. Okay, that's true for every single spot on this table. So in this table, each input or x value only has one output or y value. So that is a function. On table D, if you look there, if I ask you what is the output when x equals 4, there's two spots on that table. Either y could be +2 or y could be -2. Okay, so that's a problem. If I asked you what's the output when x equals 1, it could be +1 or -1. So at those different inputs, there's more than one different output. So at the same value of 1, there's two different outputs, and at the same value of 4, there's two different outputs, and that makes that one not a function. Okay? You've got some practice to do before your concept check. So do that practice and let us know when you're ready.